You know that feeling, right? You're on a software project, everything's humming along, and then, bam, you hit a wall. Suddenly progress just stops. And the weirdest part is, everyone's still working their butts off, the code's great, so what gives? Well, if that sounds a little too familiar, stick around, because the answer might not have anything to do with your code, but everything to do with the physics of a traffic jam. Yeah, seriously, let's get into it.
I mean, it's got to be one of the most maddening things in project management, right? You've got this awesome team, they're talented, they're motivated, your sprints are all planned out, the tickets are crystal clear, and yet the whole thing just grinds to a halt. It's like you're stuck in this massive gridlock, but when you look around, there's no accident, no big obvious blocker. So what is really going on here?
So the key to figuring this all out, it's not going to be in Jira or your Gantt charts. Nope. It's in the physics of how traffic actually flows. I know, that sounds completely out of left field, but trust me, this metaphor is unbelievably powerful for finding and fixing those hidden gremlins that cause these massive delays across your whole project.
All right, first things first. To really get this, we need to talk about something from the real world, a phantom jam. You've probably been in one. It's those traffic jams that just materialize out of thin air. There's no crash, no lane closure, nothing, just a sea of brake lights for no good reason.
So a phantom jam is a systems problem. That's the key. It's not because of one bad driver. It's something that just emerges when a bunch of perfectly good drivers all react to tiny little things. Think about it. One person gently taps their brakes. The driver behind them, they brake just a little bit harder. The one behind them, even harder. And this effect just grows and grows down the line, creating this jam wave that actually moves backwards through the flow of traffic.
And here's where it gets interesting, because this maps perfectly onto software projects. Okay, let's break it down. Each developer, or maybe a whole team, that's a car. The project workflow, how work flows from idea to code to QA to launch, that's the road. And that single little brake tap, that's any small unexpected delay. A tricky bug, a requirement that wasn't super clear, a tiny API change, and the jam wave? Well, that's the massive cascading gridlock that slams the brakes on your entire project.
And listen, this right here is the absolute key. By the time your QA team is totally swamped and blocked, that little API change that started it all, it might have been fixed days ago. The original problem is long gone, but the wave of delays it created is still rolling through the system, causing chaos. It's like a ghost in the machine.
Okay, so this brings us to what I think is a central paradox in managing projects. We have this idea, right, that if we just hire enough rockstar coders and they all write perfect code, everything will be fine. But what the physics of traffic shows us is something kind of mind-blowing. You can have a system full of individually perfect parts that is, as a whole, completely and dangerously unstable.
So naturally, we think, this must be about a few bad developers slowing everybody down, right? Our gut tells us to go find the person to blame, that one single point of failure. But here's the thing, that's just not how it works. You can have a highway full of the best drivers in the world, all following perfectly, not overreacting, and they can still create a massive jam from one tiny little brake tap. It's not about the drivers or the developers, it's about the system.
So we need to introduce a couple of key ideas here. Local stability versus string stability. Local stability is all about how one car follows the car in front of it. In our world, that's like a single developer writing perfect, clean code. It's their individual performance. But string stability, that's about how the entire line of cars reacts to a problem. It's the whole system. The big question is, does your project workflow absorb those little shocks, or does it amplify them into huge problems?
Let's walk through a super common example. Okay, step one, a small API change causes a tiny 2-hour delay for the back-end team. No big deal, right? Well, step two, now the front-end team has to completely rework their code to match, and that takes them a full day. And then step three, because of that rework, the QA team now has to rerun the entire test suite, which is a 3-day job. See what happened? That initial 2-hour hiccup didn't just get passed down the line. It got bigger and bigger at every single step.
There's actually a word for this in physics. It's called resonance. You've probably heard of the Tacoma Narrows Bridge, right? How small gusts of wind at just the right frequency made the whole thing collapse? Well, your project workflow can be the exact same. It can have its own natural frequency for failure, where it's perfectly tuned to take tiny little shocks and magnify them into project-killing disasters.
Okay, that's all pretty scary. So if just hiring great people isn't enough, what are we supposed to do? Well, here's the good news. We have to shift our thinking.
We have to stop just managing individuals and start engineering the system itself. And the best part is, the same physics that explains the problem, it also hands us the blueprint for the solution.
The research on this stuff points to 3 main levers we can pull to make our systems more stable. Think of these as your go-to tools. First, there's safety. For us, that means building in buffers and actual slack time into the schedule, on purpose. Second is agility. This is all about making your feedback loops as short as possible so you can catch those little problems before they blow up. And third, anticipation. This just means being super proactive with communication, especially about dependencies between teams.
So check out this chart. It kind of lays out the 4 states your project can be in. Bottom right, ideal stability. That's the dream, right? Good individual work, stable system. Top left, obvious chaos. That's also easy to spot. It's a mess and everyone knows it. But the one you really have to watch out for, the truly dangerous one, is bottom left, hidden chaos. This is where everything looks fine. Every developer is doing great work. They're locally damped. But the system itself, the string, is unstable. It's a ticking time bomb, just waiting to amplify the next little problem.
I mean, this quote from the original research just says it all. You can have locally fully damped, seemingly good drivers who nonetheless produce an unstable chain. As a leader, this is the scenario that should keep you up at night. It's that feeling when everything seems perfect, right before the whole project just freezes. It feels like it came out of nowhere, but the truth is, that instability was hiding under the surface the entire time.
So how do we actually fix this? I mean, we can't expect everyone on the team to be perfect 100% of the time. That's just not realistic. Instead, we need to be smart about it. We need to introduce strategic things into our process that stabilize the entire system. In other words, we need to install some project wave dampers.
And this is one of the coolest findings from all the traffic research. For anyone in management, this is seriously fantastic news. It turns out you don't have to burn everything down and start over. A really small, targeted intervention can have a huge, outsized impact on the stability of the entire system.
Get this, research shows that adding just 5% of autonomous cars to the mix, cars that are programmed to smooth out the flow of traffic, can stabilize 100% of the traffic. They basically act like shock absorbers for the whole highway, just a few of them. So, the billion-dollar question is, what's the equivalent of that on a software project?
Well, your project's wave dampers are these strategic things you put in place to create stability. For example, it could be a senior systems architect whose job is to get ahead of cross-team dependencies and smooth things out. Or it could be a really solid automated CI/CD pipeline that gives everyone fast feedback. It could be blameless postmortems where you focus on learning, not blaming. Clear API contracts. Heck, it could even be you, the project manager, actively creating some slack in the schedule to absorb those little bumps in the road.
So that's the big question I want to leave you with. Take a hard look at your current project, but look at it through this new lens. Can you pinpoint the things that are amplifying delays? And maybe more importantly, can you identify who or what is acting as a wave damper? If you can't think of any, well, you might have just figured out why your team keeps getting stuck in traffic.